Hello everyone, I'm sorry I got a little bit ahead of myself here. So in this example, what I'm going to do is I would like you to press pause and simply calculate the value, the y values, in the function y is equal to 4 minus 2x. Now what I'm going to do is I'm going to construct the table of values to graph what f of x is equal to the square root of 4 minus 2x. So the first thing I need to do is calculate the y values of 4 minus 2x. And there they are. Then I'm going to take the square roots of them. A fairly simple exercise. Now, I'm just going to talk about the values here. And I'm going to graph y is equal to 4 minus 2x first, and then work on it a transformation and a graph. But I would just like to talk about the numeric values. The square root of negative 2 doesn't exist. The square root of 0 is 0. 2, the square root of 2 is square root 2, which is approximately, I think, 1.4. Square root of 4 is an integer value 2. Square root of 6 is, I really don't know. It's sort of almost between the square root of 4 and the square root of 9, but probably closer to the square root of 4. So this is 2.3? Not too sure. The square root, no, let me go. The square root of 8 is the square root of 8, but that's really close to the square root of 9. And I'm not too sure, but I think that's around 2.8. The square root of 10 is higher than the square root of 9, 3.1, etc., etc. Anyways, don't forget your benchmarking of square roots from grade 9. So getting back to my question, I'm just going to graph this. This is the function I'm going to graph. I've even included one more point where the x value is negative 3 because I think it's very important that we understand that. I had a little bit of a rough start there starting, but I think I'm off to the races now. So this is my function. This is my function. Y is equal to 4 minus 2x. Now what I'm going to do is I'm going to transform this function, because if this is y is equal to fx, point x comma y will be mapped into, when I take the square root of that function, x comma square root y. So I'm going to take this point here, and I ask myself, actually, what is the square root? My y value here is negative 2. What is the square root of negative 2? It doesn't exist. And in fact, it doesn't exist for any value. Now, I just scrubbed that out, but that's where the y values are negative. So my square root function actually doesn't exist in this domain. However, it starts to exist right here. My y value is 0. So when I take the square root of the y value, it remains the same, a stationary point. And I'm going to take this point here, 0, 4, because it's nice and easy. So 0, 4, when I transform it, it's actually 0 comma the square root of 4, which is actually 0, 2. Fair enough. 1, 2 is actually 1 comma square root 2, which is about 1.4. So here is what I have so far, and I'm feeling pretty good about this. Now, negative 1, 6 turns into 1 square root of 6, which is 2.3, I said, so I'm just going to put 2.3. And this is looking like a curve. So far, so good, I hope. Now we get into the finer details of a square root of a function. Did you guys know that this... Uh-oh. There we are. Did you guys know that this is the point where y is equal to 1? And I'm going to just highlight 2 points in orange. These are called stationary points. So for 2, 0, what we have is the x-coordinate is x, or some value x, and the y-coordinate is 0. So when we take the square root of 0 is 0. So it remains the same. This other point, I don't know the x value, but I do know the y value, 1. And when we transform that point, it turns into x comma the square root of 1, which is 1. There we have it. These stationary points should almost be automatic. So check wherever y is equal to 1, make sure it's stationary. When y is equal to 0, and it's stationary. So now I'm going to graph this. I'm going to graph this in this following way. I'm just going to connect the dot. Yeah, we're looking good, we're looking good, we're looking good. Probably no arguments so far. However, this is an interesting point. Now, this is where my y value is between 0 and 1. So when you take the square root function has to be greater than the original function. And that's all there is to graphing a square root function. Let's move on to the next example. Okay. Some things we need to consider. We take points x comma y, and we're mapped into points x comma square root y. First things first, I'm going to take my stationary points. If my y value is 0, then my y value remains 0. So I have two stationary points, as we say, 4, 0, and negative 4, 0. Next, I have x, 1. In other words, what number, when you take the square root, does the value remain unchanged? And that's 0 and 1. That's why they're called stationary points. They just simply don't change. So here is where y is equal to 1. Right? So I have another 2 points there, and these are called stationary. These will be on my square root function. Now, a lot of people probably would start off here. 0, 8. So 0, 8 would map into 0 comma the square root of 8, which is approximately 2.8. Me personally, I would have sought out this point here, and it's an x value that I actually don't really know the x value here. It's along this line, but the y value is 4. Pardon me. Y value is 4, so when I take the square root, it changes to 2. Same thing over here. So what we have on my square root function is I have, it looks like, 5 points. Now, if you notice, I'm going to just ignore this. This is where my function is negative. So here we have x comma negative y. I'm just going to write this down so I can talk about it. But wherever my y value is negative, you cannot take the square root of a negative number. So this function will not exist wherever y is negative. And here we go. I'm going to sketch my function. I'm going to try to zoom in really close here. What we notice is my function, or my y values of my function here, are between 0 and 1. So when you draw your function has to be greater than your original function in this domain. And then now it's just about connecting the dots. Connecting the dots, connecting the dots. And again, in this domain right here, or in this range, the y values are between 0 and 1. So your square root function actually has to be greater than your original function. And it's really important that you make that obvious to whomever is marking it. It has to be within reason. And this is the trickiest part. That is, you can't bubble out like this, because then it won't be a function. And your y values cannot exceed 1. Okay. I'm going to skip a few questions here. And we're going to identify the characteristics of the following functions. I'm going to get rid of this, rid of this, rid of this, rid of this. Maybe I'll just scribble them out. Identify the following characteristics of this function. Fair enough. Did you know that y is equal to x squared plus 7 can be considered a parent function? And when this opens up, right, we have a vertex at 0, 7. Which incidentally, this is y is equal to x squared plus 7. Well, what's the y-intercept? Well, the y-intercept happens where x is equal to 0. If this is my parent function, if you notice, x is equal to 0, we have a y-coordinate of 7. So on our square root function, the y-intercept would be square root of 7. My x-intercepts. Now I'm just going to delete this ever so much. Now this is an upward opening parabola. Did you know that my parabola is upward opening? It doesn't have any x-intercepts. So for instance, there are no points on here where the x value is 0. Sorry, where the y value is 0. So this will have no x-intercepts as well. Weird, right? Now this function here. So I'm going to graph y is equal to negative x squared minus 5. So when I quickly sketch this out, what I noticed is that this is a downward opening parabola with vertex 0, negative 5. When I take the square root, what do we notice? We notice that the y values are all negative. Well, what about the square root function of that? Well, you can't take the square root of negative y values, so the function just simply does not exist.